All right, so volume of a solid or liquid to number of molecules. So this is a little bit more involved because we're starting with the volume of a liquid here, 0.0257 liters of water. Well, I don't have any way to put that into my map down here. So first I need to get to mass. Well, I can do that because I've got a volume and I've got density up here. Density is up here, and actually this unit down here should be milliliters, which is the same as cubic centimeters, so just a typo on the units. But I need to do a calculation first to convert to mass. So again, we're going back to the density equals mass over volume equation, and I want mass. So if I rearrange the equation, density times volume equals mass. So I've got the volume and I've got the density. Right, there's the density, there's the volume. So 0.0257 times 0.99705 equals the mass of 0.0256 grams. So that's where I'm going to start. Now up here, 0.0256, and that's water. So the molar mass there is 18. So 0.0256 divided by 18 gives me 0.00142. Now the mole ratio, my unknown is magnesium hydroxide, which has a coefficient of 1. My known is water up here, which has a coefficient of 2 in the equation. So I'm multiplying 0.00142 times 1/2, so 0.00071. And now I don't want mass, I actually want molecules. So I know the number of moles here. I want the number of molecules. So to convert from moles to molecules, I multiply by 6.02 times 10 to the 23rd. And when I do that, I get 4.27 times 10 to the 20th molecules. So that's the answer there. Now we're going from heat to volume. So when I'm starting with heat, okay, I can again skip this step because there's no number of moles, there's no conversion to moles. All I'm doing is taking the amount of energy I'm given here, which is 100 kilojoules, and that's where I'm starting. I'm starting as if I've already got the number of moles. Then my mole ratio, the unknown, is hydrogen gas, which has a coefficient of 1. My known is energy, and up here in the equation we have 353 kilojoules. That's the coefficient. The number of kilojoules in the equation is the coefficient if you're dealing with energy. So 100 times 1 over 353 is 0.283. And now we're trying to get to volume of a gas at STP. So remember, any gas at STP has a molar volume of 22.4 liters. So 0.283 times 22.4 liters comes out to 6.34 liters. And that's the answer there. Okay, limiting an excess reactant. Alright, so we've got two solutions that are mixed together. So in this case, we're given two starting materials, or two reactants from the equation up here. Silver nitrate here, and iron chloride, iron 3 chloride. So the first thing we have to do is figure out what is the limiting reactant. Well, in order to do that, we have to use this chart, which is a little different. So we're going to start with silver nitrate over here, 18 grams, and iron 3 chloride, 32.4 grams over here. And again, it doesn't matter which one you do on which side, just that's the order they were in. So that's the way I did it. So 18 grams of silver nitrate, and if we look up and add up the silver nitrate, silver plus nitrogen plus 3 oxygens, it has a molar mass of 170 grams. And on the other side, the iron 3 chloride has a mass of 162.3 grams, and we've got 32.4 grams of that we were given. So we divide on both sides and move one step over toward the middle. We've got 0.106 moles of silver nitrate. We've got 0.200 moles of iron chloride. And this is going to be divided by 3. This is going to be divided by 1 because those are the coefficients of each reactant. And I'm not even going to do the calculation because this number here is already smaller than this number, and I'm dividing it by 3 instead of 1. So I know it's going to be smaller. This is going to be something like 0.033, and this is still going to be 0.2. So the smaller number is always the limiting reactant. So our limiting reactant is the 18 grams of silver nitrate. That's the first answer. Silver nitrate is the limiting reactant. Given that limiting reactant, how much silver chloride will be produced? Well, we calculated the moles of silver nitrate in the last part of the problem, trying to figure out the limiting reactant. So I can skip this step. I've already done it, really, so I'm not skipping it. But I don't need to fill in that box because I already know that I have 0.106 moles of silver nitrate. So my unknown here is AgCl, which is up here and has a coefficient of 3. And my silver nitrate also has a coefficient of 3 in the equation up there. So 0.106 times 3 over 3 is 0.106. And then I'm going to multiply that over here by the molar mass of my unknown, which is the AgCl. And that has a molar mass of 143.5 grams. 0.106 times 143.5 is 15.2 grams. That's how much silver chloride would be produced. And the last part of this question is how many grams of excess reactant would remain? Well, we know this is the limiting reactant, so I'm going to start with that. And again, I already know it's 0.106 moles of that. So the unknown in this case is the other reactant, FeCl3. It's got a coefficient of 1. My known is my limiting reactant. It's got a coefficient of 3. So 0.106 times 1/3 is 0.0353. And then I'm going to multiply that by the molar mass of iron 3 chloride, which is 162.3 grams. 0.0353 times 162.3 is 5.73 grams. That is not, however, the actual answer because the question is how much is left. Well, this answer tells me how much was used. So in order to find out how much was left, I have to go back up and start with how much of the iron 3 chloride did I start with, which is 32.4 grams. And then I take away the amount that was used according to the calculations we just did, which is 5.73. And I find out that there should be 26.7 grams of iron 3 chloride remaining. So that's how much excess should be there.